Alright, hello everyone. We're Team 930, and I'll welcome you all to Question Cave. We'll be answering a few questions that you guys have left on Discord or the live stream chat. If you have any more questions after the stream, please feel free to leave them on our Discord.
And
Uh,
to start us off, we're going to have Hussein talk to you about state machines.
yep. In programming, a state machine is an abstract machine that can be in any number of finite states at a given time. We use these state machines in our code to keep track of the robot state and have the robot perform specific tasks based on that state. Last year, our team used the state machine to keep track of our endgame climb, and so we know which bar the robot was on. So that way, we could hold one button, and then the robot would move fluidly through the entire climb. A hypothetical use case for this year would probably be auto balancing on the chart station. In this case, you'd have three different states: leaning forward, leaning backwards, and being level. You could use these three different states to send three different commands to the drivetrain in order to get it to balance. In last year's code, we implemented a state machine using switch cases, which is what I would recommend like every team do. Every each case would be the robot state, and then the switch case would run the command based on the case that was fulfilled.
And another reason to use state machines is they can be a useful and versatile tool that allows you to simplify the programming of your robot so you have all your states in one command. So you have all your state commands in one state rather. So you can simplify, and understand more easily what is happening when the robot is in a specific state. And it also helps when you're debugging, as you don't have to jump through a whole bunch of different files and different commands to try to find what's causing your program to error out.
Alright, I'm gonna switch to a different topic. I'm gonna be talking about how we get ready for competitions. So, as programmers, we put together documentation that instructs people on how to use common programs. We also printed out flyers for Bytes, which some of you may have received, and that might be a reason why you are here today. We prepared a list of everything we'll need for the competition. Usually, the list consists of all the computers, wires, and documentation we will need for the competition. We update our programs such as Ref clients and Visual Studio Code using WPI-lib programs, and such as Ref using WPI-lib and ensure that we have the latest code on our computers by using source control software such as GitHub. We also practice answering questions that the judges may ask. We also did a lot of testing by simulating the robot and testing on the real thing. For simulating the robot, we use Advantage Scope, which allows us to see our robot on a 3D field. It also will log the data that we tell it to log.
And additionally, we also extensively document the code, the functions of the robot, and the hardware devices on the robot that the programming team interacts with. We document everything from the LEDs and the Arduino that controls the LEDs found on the robot, indicating what game pieces we want to pick up, to documenting the configuration of our AppleTake cameras and the gyroscope.
Um, for the question, what strategies can you use to ensure the robot code is reliable and maintainable? The way we do this is through our source control. We use GitHub, which is a free source control software that helps us to manage our code. You can create multiple branches with different things, and then with multiple branches, it's a good way to ensure you don't break like your code if like, let's say you have like a bug in one of the branches, it's not gonna like affect all of the code. It's a good way to like maintain and keep it reliable.
Yeah, and then we incorporate machine learning. Evan, do you want to answer that?
I'm not really quite sure.
Okay, so we incorporate machine learning techniques into our robots programming. We don't really have anything that's entirely machine learning.
Yeah, we don't really incorporate. Like, we're not at that stage. Like, or we don't see the use quite yet of incorporating machine learning techniques into enhancing like our robot's performance. Um, but
We
that might be something we might do in the future. Maybe we will have to see if it's advantageous enough for us to do
the
so.
closest thing we probably do is training the infiltrate cameras to recognize the targets, and but that's more tuning than it is machine learning.
Yeah.
The next question was, what are some best practices for integrating sensors such as gyroscopes and accelerometers into your real-life code during FRC 2023? We use gyroscopes to tell where our robot is on the field, and we also use the gyroscopes to determine our angle so we can balance on the charge station automatically.
Um, yeah, that's a good question. And then, yeah, gyroscopes and accelerometers. It's important to just know what the procedures for those are because we have been caught before of having them, angled wrong or something, and then when we start the match, our robot goes into a wall because we didn't align it properly.
Great. What are some common pitfalls to avoid while writing code, and how can you ensure your team is writing high quality and efficient code? Well, we have some documents that they have our standards for how you should write and organize our code. And then once we're done writing through a program or a specific program, we will go back through our code and make sure that it is all neat and organized and follows those code standards.
Yeah, and we have a extensive documentation of what code standards each member of the programming team should be following. So, like when to leave comments, how to leave comments. Make sure your comments are readable and understandable for the next person. Don't push up code that's broken if you know it's broken and you can avoid it. Um, and just we review our code and test it in simulation before we push it up to ensure that we're not pushing broken code. You saying you have any more thoughts on that?
In terms of efficiency, we use like command base, which is in what we found to be like the most efficient system for writing code. It's a nice way to organize your code into like easy to read and easy to write, like classes. So we found it to be the most efficient way to organize your code and
Yeah.
easiest way to create new code.
And then pitfalls that we commonly encounter when writing code is we occasionally will have comments that don't quite make sense, and we're constantly trying to improve our commenting system and make sure everybody understands how to leave good comments so that another person can come and look at it and understand what that comment does instead of just being in the dark.
All right, that makes sense. For the next question, we have how can you use path planning algorithms to optimize your robot's movement during matches? So we use a program called Path Planner. We get it from the Google Store, and we will then program our path that we would like to run for our autonomous through there, and then we can add in events and commands into there, and then that will be running during auto.
And Path Planner is really powerful because it allows you to tune really, really minute things and very precisely, as opposed to having a set point of values in the code that the robot's going to go to. Path Planner allows us to easily visualize what's going to happen to the robot while we're running it. It might not be perfect, but it's a heck of a lot better than going to a specific place.
About using FaceTime on your phone, you're not able to do that. I think the best way to do it would be on your computer, cause it's just easier to like see. And since it's only we get it through the
The Microsoft
Microsoft
Store,
Store,
yeah.
it's basically a Windows exclusive thing. So yeah, you probably be able to use it on the computer only.
You saying you want to take the next question?
What are some strategies for handling sensor noise and other sources of uncertainty in your robot's code? Um, we have well, this goes for like a lot of things on our code. We have
We definitely have a lot of sensors that
yeah.
on our robot that definitely could uh, get noise from other electronics, from wiring and stuff like that. And we just essentially try to test and determine how much noise we're going to get and determine how much the degree of freedom of those values of what's going to be valid, and then we can determine kind of what we will accept as an input.
Yeah.
And uh, yeah, the sensor noise we definitely try to mitigate in a hardware standpoint. from like wiring and from a software standpoint. And the next question, how can you use software debugging tools such as loggers and debuggers to identify and fix problems in the robot's code? So I guess I'll take this one. So we use Advantage Kit and Advantage Scope. They're part of the same system of tools. And the nice thing about Advantage Scope is it allows us to graph essentially any part of the robot that we tell it. We can tell it we want to log all this data, and then it will put it into a nice little graph, or we could use a 3D field to outline where a robot is moving on the field and so on. But if we have an issue, like say our intake isn't going up to the correct height, we can pull up Advantage Kit and Advantage Scope and see where it is being commanded to go and where it's actually going.
Yeah.
And usually that helps us a lot with tuning. And also you can use um, you can import log files into Advantage Kit. So say something didn't go quite right in a match and you want to see, what was the robot doing during that point of a match where something went wrong. You can open the log file and tell it, hey, I want to see what was going on at this point and what parameters I want to see. So like, where was the intake? How fast was the swerve going? What direction was the swerve going in? And then if you have any issues, you can always look at the FRC driver station log that you can just pull off the RoboRio and put on your computer, and you can see, oh, there's a warning here. Like there's some issue with the CAN, there's some issue with an encoder, something isn't initialized right. And we often do that at competitions, just trying to continually strive to be better.
Yeah.
Uh, Next question is how can you use telemetry data such as battery voltage and sensor readings to monitor your robot's performance? And what are some of the best practices for visualizing and analyzing this data?
Okay, so for this one, um, the best practice we use for batteries, voltage specifically, would be just in driver station. It shows you your robot's current battery voltage, and if you pull up the like log, you can see like the all the like voltage over time of your robot, and you can see if it's spiking or if it's like getting too low, and then you'll know if you need to change the battery or not based on that data.
Yeah, and definitely battery voltage does have a very significant impact on your robot's performance. So, say you have 13 volts on your battery versus 12. A 13-volt robot is going to do a lot better than a 12-volt robot. It's going to move faster, it's going to extend things faster, and it's going to the compressor is going to work better, stuff like that. And so it's very important, even before you start the match, to see what voltage your robot is at to ensure that you're going to get the best performance. If your robot is not um, high enough voltage or around 13 volts, I wouldn't use that battery. I would pick a different one and try to ensure that you're getting the best performance. And then in terms of visualizing it, you can look, as I mentioned before, Advantage Scope is a nice tool to see, what's our battery voltage versus what are we running on the robot. Driver station logs will also do this. If you don't use Advantage Scope, you can see, hey, I started the intake and all of a sudden I dropped by a whole volt just trying to keep the intake running. And you can optimize, hey, when I'm putting out the intake, I only want it to run for about 5 seconds or something like that to intake. I want to pick up the ball in 5 seconds. I don't want to have it continuously running so we can free up power for other parts of the robot.
Yeah, and also in terms of optimizing, you can use this um, thing called PID controllers. It helps to um, control the amount of voltage you're sending. So you send it alternates the amount of current you're actually sending to the motor to keep it like as efficient as possible. So you're not overpowering it or underpowering it, and so it's a good way to basically control how much like keep your battery health good.
And if you use shuffleboard, you can even have like a little tile on shuffleboard that'll tell you how much stuff is drawing if you choose to. So that way, when you're in a match, you can say, "Oh, we're really dropping the voltage. We should stop doing this resource intensive thing and move to something more simple, like that. Like extending the intake is going to take a lot of power, but let's say doing endgame just on the swerve is going to be a lot more less power hungry.
Yes.
So it's just a combination of software with PIDs and also some just intuition of, oh, I'm using too much voltage, I'm going too fast, we need to slow down, otherwise we might not have enough to finish the match in one piece, really.
Uh,
Uh,
the next question is, should I buy batteries each year, or would previous batteries work just as good?
I guess I'll take that question as somebody who is in charge of battery management for a year or two. Um, it can be So, yes, I would recommend buying new batteries every year, but you can use the old year's ones. Oftentimes, the old batteries are better than the new year batteries because they have more cycles on them and they have more capacity. The new ones that you've used once or twice in a practice, so say you're just running your robot at your shop, those aren't going to be as good as the batteries that you've had for maybe a year or two. I mean, obviously there is things that will prevent you from using a battery year over year. So I would recommend collecting that data and putting it into like an Excel sheet that's calculating like what is the average time that this battery is being used? What is the average resistance that this battery has? What's the average voltage it has? So then you can determine, hey, do I need to replace this battery or do I need to keep this for another year? So oftentimes it's kind of a misconception that you have to replace them every year. It's good to keep many, many years of batteries and you just collect data and say, oh, these are the worst ones that we can take out. And then you just buy ones to replace it and keep cycling.
yeah. Sensor fusion techniques such as common filtering to improve the IQ library of robot sensor readings.
The,
Oh,
the next
okay. So the next question was how can you use sensor fusion techniques such as the Kalman filtering to improve the accuracy and reliability of your robot sensor readings? Well, programming wise, we don't really use these like fusion techniques. When it comes down to sensor like accuracy and reliability, we mostly view it as an EMEC issue, but also in our code for the accuracy part, uh, like for we've started using the cameras as ways to get data on the robot's position instead of purely using the odometry's like sensor data. So we basically cross-reference the two, and so we make sure that the robot's position in our code is as accurate as it can possibly be, like between the cameras and then the odometry sensors.
Yeah. And tuning the cameras is a very time intensive task, but once you get it right, it's going to be good. So, like, you have to continuously improve the tracking of the April tags as you set up the camera. So, yeah, what's the focus of the camera? How is the camera? So, we use Raspberry Pi 4s. How is the camera going to interface with your robot code? And is it being tuned correctly to be able to tell you the best, the information correctly, essentially?
yeah. The next question is, what are some best practices for implementing safety features such as emergency stop buttons in your robot's code, and how can you ensure that your team is following proper safety protocols? I can take this one. So, for an emergency stop button, we just disable the robot through driver station. But for safety protocols, we always wear our safety glasses when we're out around the robot. We also always make sure that before we enable the robot, we give a countdown really, really loud, so that everyone in the area knows that we are going to be enabling a robot and it is a safety risk.
Also, in addition to that, before we test anything on the physical robot, we always run it in simulation in order to ensure that it does what it's supposed to be doing. There are no like rapid like movements or anything that could end up breaking the robot and then maybe injuring someone that's working on it. So we always run it through simulation before anything, and then after that, when we first run it on the robot, we always make sure that it's not running at full speed and that it's running in like a safe and controlled
manner.
yeah manner in order to ensure that everyone's safe. And then we only start speeding it up once we ensure that everything runs as expected and it's safe to continue make improving and making it faster.
That's a good point you're saying. And then also, it's very important to us that safety is our number one priority here. So our goal is to have a safe robot as possible. So we teach all our programmers to call out when they're going to enable, uh, count down when they're going to do major robot events, like I'm going to move the intake. And when that happens, we always have somebody whose finger is on the enter button, which kills the robot immediately.
Yeah.
Uh,
Alright, next question.
how can you use unit testing and integration to ensure that your robot's code is functioning correctly?
Um, okay, so for this one, I'll use the R as an example. Um, First off, before we even like test like um, whole arm commands, we always test the individual parts of the arm. So we'll like let's say use the rollers individually to make sure that they're working correctly before we, and then we like move the manipulator to make sure that's the angles are working correctly, and then the whole arm to make sure that's working correctly. And then after we ensure that all that unit testing is done, when we go to integrate it with our let's say our autonomous commands, we make sure that it all works like seamlessly together, and all the angles are correct, all the like commands work as intended. There's no like safety issues with any of the commands or any of the features of the code.
Yeah, and we also um, use unit testing with Advantage Scope slash Advantage Kit, and we can see, yeah, what are we programming it to do, and what is being sent to the motor to go to, and what it's actually doing, and then we can adjust it to meet the expected value. And then the next question: how can you use data analytics to optimize your team's performance during competition, and what are some of the best practices for collecting and analyzing data? I guess I can take that one. So it's really, really important to collect data while you're at competition, while you're in that actual competition environment, and learn from it. So what we do is after every couple matches, we download all the logs from the Robo Rio, and then we wipe it clean for the next set of matches and keep doing that. So we get all the data, and if something doesn't go right in a match, is a very simple fix to go look at. Hey, this was what was working in a previous match. What did we change? Here's what's actually happening now, and we can review those as a team, and just it's a nice collaboration tool to be able to see, what is happening exactly.
Yeah.
And it,
Also, we also track like cycle times
yeah,
of the robot, so we know like if there's areas that we can like um, speed up the cycle time so
yeah,
our robot is like scoring as points as efficiently as possible and is like and scoring as many points as possible in the shortest amount of time possible.
yeah. So we'll analyze how long does it take us to pick up a cube in autonomous and go on the charge station, or how long does it go take us to go up to the substation, grab a cube, and put it on the rack, and just try to make that as fast as possible, because the faster you do that, the more points you'll get, and the better you'll do.
Yeah.
The next question is: what are some strategies for implementing real-time processing of sensor data in your robot And how can you ensure that your code is running effectively with that data?
I guess I'll take this one. So for the, I'm gonna talk specifically about cameras. For the data of the cameras, we use um, like a class, and then we get all the data from all the cameras, and then we find out which one like is the most accurate, and that's the one we actually send to calculate the robot's position. So it's a good way to basically a good way to check it that your data is accurate and that it's and the code was using the correct data when it's running all of its function, like all the functions.
Essentially, the camera is reporting what it expects where it is and what it's actually seeing where it is.
Yeah.
So it can get confused at times, but we just have to code it in a way that it's going to take its best guess at where it is and where it should be, and it's going to use that.
Yeah.
Thank you for watching the stream. If you have any remaining questions, please leave them in the Question Cave channel in our Discord. Our next Question Cave will be at April 1st at 1 p.m. Central Standard Time. We hope to see you there.